Hi guys, welcome back to the shop. Today I'm going to get on the AT-1 MX crankshaft. We're going to be taking an AT-1 crank that has the electric starter dynamo ignition, and we're going to put the CT1 flywheel type crank half on that side. We'll be using the other side, which is the same. And first thing we're going to do is get all the relevant information that we may need. A lot of times you don't need it, but if you have it, if a problem arises, then you've got the information. So that's the first thing we're going to do. Okay, again we're going to use the AT-1, but we're only going to use the clutch side. This side here we're going to replace with this type, which is the CT1. It's got the longer snout on it for the flywheel. This is all the starter dynamo type stuff. So we'll be changing all that out. And the first thing that I did, and you know I've done this before, so it's not a surprise to me that everything is right. But you know, you just need to measure everything, you know, measure the diameter here, then measure the diameter of this one, as long as they're pretty close. You want the thickness of both, pretty close. And of course you got to get the bearing on, or get it on through the bearing, so you've got to be close to whatever that is. I think I didn't get this one on straight. 24.97. Yeah, 24.98. Okay, so we're right there. You just gotta make sure that it's pretty close. And the actual axial play is the distance between the shim here and the rod. And I'm at about 22. This is a snug 22. And I believe they call for less than that. Let's see. 15 to 19 thousandths. Actually, I need to get this off of millimeters, and since most of my equipment is my dial indicators and everything else is imperial, that's where you need to stay with one or the other, and then I convert all my metric measurements over. Anyhow, 22 is what I ended up with. They want a maximum of 19, but that's all adjusted as you squeeze it together, so that's not something that is real valuable information at this point. It's just we're kind of looking at the health of the one we're tearing apart. There is a maximum also, but that's 15 to 19 is where they want you to set it up at. They can actually be wider and it won't hurt anything, but we're going to set it up according to what they tell us to do here. The only other thing that I can really say at this point is to check the width. And again, it's not going to make a whole lot of difference because we've got to get this to whatever they say. So 2.208 is what we're ending up with there. Now we'll take you over to the lathe, and this is immaterial too. There's really no need in putting it in the lathe and looking at the to see how close the tolerance is, because we're swapping out this side anyway. But there again, it's just good information to have, and we'll check the health basically of the one that we're tearing apart. So let me get you over there. Okay, let's get you down here where you can see what's going on. Okay. Well, this initially is looking pretty good here. I'm lucky if I can get them back this close. Okay, I think we're zeroed out on both of them. This mag side right here, I think you can see that. Yeah. I'm seeing the run out here at about 2 thousandths. Right there, a little less. And then on the clutch side over here, oh, that's really good. About 1 thousandths. I'm hoping you guys can see that. I actually had a few comments on Facebook about me never showing the measurements, and I'm not real sure what those, I think those guys they're watching the wrong video and commenting on mine, because I believe that most of you that watch it all the time know that I do this. I'm usually very careful about showing everything that I get, and there are some times when it's real close, particularly on the boring operations, when I'm still at the milling machine. It's so close that I can't get a dial bore gauge, so I don't show that sometimes. But with the finished product and everything, I always show that. So I'm not sure what these guys are talking about. I had a couple of them that said I never show the measurements or talk about the measurements. So I just want to make sure everybody can see it here. Anyhow, that's where we're at now. But this is really useless information, other than we're just checking the health of the crankshaft before we take it apart. And we're just hoping at this point that we can get as good as this. Okay. Okay guys, let's get it set up here in the press. Using my handy dandy little plate that I made here. And you just want to make sure that everything is clear underneath. Let me get a flashlight here and I'll show you. Okay, I think you can see under there. You just want to make sure that you're not hitting anything, and when you start the press, you want to make sure that you're holding on back here underneath so you don't drop your good part on the concrete. Okay? Okay, let's see what she's going to do, how tight it's going to be. I'm just positive my hand's in the way there. Let me see if I can get some better camera angle here. All right, I think we can live with this. Okay, here we go. Just going to hold on to it a little bit. All right, it's pretty tight. Okay, let's get the other side, get the pin out of the other half here. Okay, how's your view there? Here we go. Okay, everything looks good. Oops, looks like it moved a little bit there. Okay. You ready? Not too bad coming out of that side. Okay guys, it looks like we had a little rust in there. It actually didn't look too bad from the assembled view, but you can see some rust here, and you can definitely see it in the rod. I'm hoping you can see that right here in the bottom. Let me try to get you up a little closer. Okay. Right here in the bottom, and then just across to 180, there's a little bit on this side and on this side. And you can see the same issue here. You got a little bit of rust right there in the pin, and a little bit, just about 180 on the other side. And we've got, I'd say normal wear on the washers. A lot of times you can reuse these washers, but you can still get them. They're not that expensive, so I just buy new ones. And a lot of times on the Yamahas, you can reuse the rods too, but I wouldn't want to do it in this case with the rust pitting in there. The upper part looks pretty good, and I've got one here that is a used rod, and it actually looks very nice for a used rod. And I'm not sure whether I'm going to use that or not. I've got a new one. I'll probably just use the new one. But, most of the time on these little Yamahas, if you didn't have a big issue, you can just get a new bearing and pin, and you're probably good to go. And some new thrust washers. But, there's the other side of the coin too, where you're saying, hey, this is a lot of work. I'm just going to go back in with all new parts. And, that's probably the best option. However, just because it's new, doesn't mean that there's nothing wrong with it or that it's not going to fail. You just have to remember that. But, that being said, your chances of, if you go back with all new stuff, your chances are better. So, that's probably where we're going to go, because as much as I enjoy messing with these old bikes, I don't like to redo things. Here is the clutch side. This is what we're going to reuse. I'm going to clean this up. This one here is in pretty sad shape. It's pretty rusty here on the end, so unless I do a repair like I did on the Suzuki, there's just no point. And there's a lot of these out there, good ones, if people need this type. So I'm not going to mess with that at this time. But this is the one that'll be going back on, and we'll be using all new components then. Okay, let's take a look at the replacement parts. Here's the flywheel haft that was from the old one. It's got a few little rusty spots on it, like right here, but it's nothing bad. I'm not going to worry about it. This should be just fine. And I cleaned it up. It compares, I guess, kind of to this one. And it measures out, specs out really close to the same size. And now what I want to do is take a look at the components that we're going to put in here. Couple measurements that you need to make sure of before you get into this. And you know, it's just kind of obvious stuff. Let's look at the original Yamaha. That's right here, and just take a look at the width. Okay, 0.626, and the replacement. This is a Pro X. 0.629. So we're okay. And that's not a big deal here, but 710 on our upper bearing. And 710. Probably the most critical measurement would be the length. And all you have to do is just measure from center to center there, and I'm getting 3.189 on the Yamaha. Actually, I think it was 8.8, and then when I pulled it out, it went to 8.9. Maybe there's a better way to do this. Maybe I should hold it, because I'm getting completely different reading here and shouldn't be. Okay, 3.188 on the Pro X. And 3.188 really, 1875. So this should be a comparable rod, and I know it is because I've used many of these. But if you don't have the measuring equipment, you can at least just put them side by side and get a good idea if it's going to work or not. Now, one thing that you'll notice is the oiling of this. See, the Pro X gives you the oiling slots on both sides. Yamaha doesn't. This is a beefier rod, no doubt about it. But see, you still have the oil grooves here. You have 5, and you have basically 4 here. This one makes up, 2 of those. So I think we're comparable everywhere. So I've used many of these. These are good rods, and the good thing about them is they're a little bit lighter. So that will give us a little more RPM. Let me move this up so I can move that up and you can see. Okay, 152 grams. And 136 grams. So we've got a little weight savings there. It's a little easier for the engine to build those R's, so it should be good. Now, I've got some, none of this stuff is, this is kind of gee whiz information. you know, some people care about it, some people don't. It's not necessarily, you know, information that makes a difference at this point. You just want to put a rod in. But there are a few differences that we can look at too. Here are the Pro X thrust washers, 41 thousandths, 41 thousandths, and this is Yamaha one. Looks the same, comes in a Yamaha package here, and 45, or 40 and 5/10 thousandths. So really, that's what it is, 41. So that's pretty close. Let's take a look at the old ones that come out, and we'll see how much wear they had. Not much. 30, almost 40 thousandths on that one. And 40 on that one. So you could certainly reuse those if you want to. And I've reused them before. Now, another gee whiz thing is the pin. Okay, I'm going to mic this out. Okay, getting right at 0.866, and let's see, 3. 0.8663. Here's a Yamaha pin. All this stuff here is Pro X. Exactly the same, 0.8663. So no concernable difference there. Now, what I thought would be interesting to find out is what the interference fit is going to be. So I went ahead and set up my my bore mic for a small hole. Let me kind of move some of this stuff out of my way here. Trying to keep all the Yamaha stuff on their original packages. Okay, so we know that the pin is 0.8663, and I've already set my sun and bore gauge up for this hole. I know this is going to be kind of hard to see the whole thing here, I think. So 0 on this would be 0.8663. Okay, I think you can see there that the hole is actually 2 and 6 thousandths, or 2 and 6/10 thousandths smaller than the pin on this one. This is the new side that's never been installed, NOS part, and this is the part we're going to reuse. I'm trying to keep all this in view here. It's kind of difficult to do. Okay, this one is not quite as small. It's 2 and I'm seeing about almost 3 10,000ths. So about 3 10,000ths difference between this one and this one. Like I say, this one has never had a pin in it, and this is a reused part. So as you can see, This one we're probably going to have a little bit harder time getting the pin into. When you're talking about an interference fit, especially when you're already 2 thousandths bigger than the hole, another 3/10,000ths is going to make considerable difference. So we'll see when we get ready to put the pin in, which is coming up. But anyhow, this was just some good information. Again, if you watched my other video, I did another one on a CT1 crank, which is the same actually. I just have a pin that I use to keep everything close as I'm putting it together. I'll be using that pin again until I get things started. It's real difficult to keep it that way. Once you start getting the pin in the middle, this wants to jam up. So you've got to just kind of, once you know you've got the pin started straight, then pull your alignment pin out. And you don't have to do that, but it's something that I do that helps me get everything lined up. So what else is there here? I think we've covered it about all. Yep, I wrote down about all the information there that I just went over with you. So the next thing we're going to do is install the pin in the virgin flywheel side first, and then we'll put this one on. So let's get over there and do it. Okay guys, just to show you a little bit of what I'm up to here. This has a 25 thousandths recess right here, and I don't really want the pin coming out into it. The pin actually, I think I forgot to show you that, is about 25 thousandths shorter than the other pin. So I'm hoping that just by coming out to here, actually I've put about 28 thousandths worth of shims right here and taped it to it. And then I'm putting it over the my press bar here. So that way I should not press further than that. I can always go more if I need to, but right now I don't want to do that. Okay, we've put a little bit of oil in there, not a lot, and it's just a real thin oil, and a little bit on the pin also. And I'm going to drive with a aluminum piece on top of it. Excuse my hands here while I get this started. Trying to keep it straight. That's home. Okay, looks like it did what I needed it to do. Let me pull my tape off. I probably need to push it in just a little bit more, but it's more like about 1/1000ths. So as far as this goes, I'm just about there. Did not want it to come out to here, and it would have if I hadn't put that shim here. So there's our pin installed in the NOS flywheel half. Went in pretty hard. I'm pretty sure a 10-ton would not do it. It's going to take at least 20, if not more. Okay guys, we're back over at the bench. I just wanted to show you where we're at here. You just saw us drive the pin in. And it's just, I'd say it's within a thousandths of being, maybe two at the very outside, of being flush here. And the reason I wanted to do that is, number one, this pin is actually about 28 thousandths shorter than the original pin. And why did I want to do that? Because this side doesn't have this. They are the same width, basically. About 0.933 on this new one. Now I'm measuring across here to the back. Let's do it again here just to make sure. Now there I'm getting about 930. It's probably not going to be completely concentric. 926. But I think we could safely call it 930. And this one, get away from that rusty spot. There's about 925, 930. But you can see that there's 922, just a little, 924. But we're very close to the same thickness on both of these. It's just that they made this recess for whatever reason on this one. And I've seen these before. I've had to, I think the CT1 that I did, I had one like this, and I had to do the same thing with the shims. So it's common to see both kind, the full width ones and the recess type. There's probably a little bit of difference in the weight. I've never measured them, but I've put them together like this before, and I've never had any excessive vibration or anything like that. So I think we're good to go, and we're really getting long on the video. So there's just no way that there's time to finish the assembly and then set it up in between centers and true it up. So we'll do that in the next video. But we've just about got it. We've probably got another 5 or 10 minutes in assembly, if everything goes right, and then setting it up. It just depends on how bad it is when it goes together and what we've got to do. So there you have it, guys. We've just about got the crankshaft put together for the AT-1 MX, and the next day or two I'll finish it up and put it between centers, let you see everything as far as our dimensions, just like I always do. And everything should be okay. I don't anticipate any problems, but you never know. You can be off where you've got to pinch the thing or you've got to widen it or whatever. That rarely happens. Usually all you've got to do is just move the two halves, with a lead hammer or bronze hammer. But I don't anticipate any problems. This one, that pin really went into that NOS part hard. You're not quite as tight on the other side, so I anticipate it being a little bit easier. But that's one reason I wanted to put it in this side first, is I knew it was going to be harder. So the next video, we'll try to finish her up and get her straightened up and all spec'd out and everything. So thanks for going along on the ride, and we'll see you next video.